Hi, everyone, welcome to my channel again. Today, I am going to share my 9th video of regression analysis, which is the prediction of future value. Before watching, please like, comment and subscribe to my channel. Your support will encourage me to produce more videos related to statistic, Lean Six Sigma and operation management. An important application of a regression model is predicting new or future observations y corresponding to a specified level of the regressor variable x. You can use regression equations to make predictions. Relationships, or correlations between variables, are crucial if we want to use the value of one variable to predict the value of another. We also need to evaluate the suitability of the regression model for making predictions. What is the prediction interval? Prediction interval represents a range that a single new observation is likely to fall given specified settings of the predictors. After you fit a regression model that provides an adequate fit to the data, you can use the model to generate predictions based on specific predictor values. With this type of interval, or predicting ranges for individual observations rather than the mean value. For example, for a 95% prediction interval of 5-10, you can be 95% confident that the next new observation will fall within this range. What is the difference between confidence interval and prediction interval? Confidence interval represents a range that the mean response is likely to fall given specified settings of the predictors. On the other hand, prediction interval represents a range that a single new observation is likely to fall, given specified settings of the predictors. Unlike confidence intervals, prediction intervals predict the spread for individual observations rather than the mean. The prediction interval is always wider than the corresponding confidence interval because the prediction interval depends on both the error from the fitted model and the error associated with future observations. The formula of prediction interval is shown as below. Y hat sub 0 is the fitted response value for a given set of predictor values. Alpha is level of significance. N is number of observations. X sub 0 is the predictor value. MS error is the mean square error. Let's take a look at an example. Data from a sample of 10 pharmacies are used to examine the relation between prescription sales volume and percentage of prescription ingredients purchased directly from the supplier. The sample data are shown in table below. The best fit line is y equal to 4.7 plus 1.97x. The best fit line is a line that actually minimizes the sum of the squares of the deviations between the observed values of the dependent variable and the predicted values of the dependent variable, with respect to slope and intercept. The slope is 1.97. We can conclude that the estimated average increase in sales volume for each additional percent of ingredient purchased is 1.97 or 1,970 pieces. Let's determine the sales volume when x equals 20. Substitute the x with 20 in the regression model and we get the sales volume of 44.1. Next, we will further develop the prediction interval, which represents a range that a single new observation is likely to fall given specified settings of the predictors. We have obtained the necessary information needed to calculate the prediction interval except mean square error. Based on ANOVA table in regression analysis, the mean square error is 81.4. Finally, the calculated prediction interval is between 21.7 and 66.4. Next, I will share with you the method of plotting prediction intervals in fitted line plot using Minitab. First, click Stat, Regression, Fitted Line Plot. Complete the following steps to specify the data for your graph. Click Option, select Display Prediction Interval. Click Graph, select 4 in 1 under Residual Plots. To confirm that the regression analysis is valid, verify assumptions. About the model error term. 3 major assumptions, which are normally distributed, constant variance for all fitted values, random and independent over time. These assumptions provide the theoretical basis for the t-test and the f-test used to determine whether the relationship between x and y is significant, and for the confidence and prediction interval estimates presented. If the assumptions about the error term appear questionable, the hypothesis tests about the significance of the regression relationship and the interval estimation results may not be valid. An analysis of the residuals is an important step in determining whether the assumptions are appropriate. In this example, the residual or error fulfill the 3 assumptions of normally distributed, constant variance for all fitted values, and random and independent over time. Hope you enjoyed this video. Remember to subscribe to my channel so that you will not miss out my next videos. Bye, see you next time.